Right then, in this example, we're going to be looking at factorising quadratics using the difference of two squares method. This is a method that's useful in specific cases where the following is true. We have a quadratic that has no linear term, so no x term, and one of the terms is negative. So the two examples we're going to do on the left are cases where you can use the difference of two squares. We have x squared minus 4, so we have a quadratic term and a constant with no linear term, and one of the terms is negative. Similar with b, we have a constant and then a quadratic term. This time the quadratic term is negative. It doesn't matter which one is negative as long as only one of them is. Let's get started with factorising the first one then, x squared minus 4. To use the difference of two squares, we'll have two pairs of brackets and we'll put x into both brackets here. That will get us the x squared. If we want to get minus 4, we can have plus 2 and minus 2 in the bracket, because plus 2 multiplied by minus 2 will give us negative 4. The key to using the difference of two squares is that we have the same terms in both brackets, but one has a positive term and one has a negative term. And we can see the consequences of that if we think about expanding out these brackets. We would get x times x, which is x squared. We would get plus 2 times minus 2, which is negative 4. And then the other parts will cancel out because we would have positive 2 times x, which is 2x, and negative 2 times x, which is minus 2x. So they cancel to leave us with x squared minus 4. Let's try the one underneath. We'll have some brackets. If we want to get the 16, we need 4 and 4. And then we want a negative x squared, so we'll have plus x, which we could then multiply by negative x. So 4 times 4 gives us 16. X times minus x gives us minus x squared, and then the other two terms will cancel. X times 4 is 4x, 4 times minus x is minus 4x, and we get what we want. One thing that's worth being aware of is that often when it's appropriate to use this method, you will see square numbers appearing in these kind of questions. The ones that we just did had 4 and 16 in them. Now, it's not always the case that these numbers will be square numbers, and the method does still work with other numbers. But if you do see square numbers in this kind of question, it's an extra clue that you're doing the right thing. Okay, here's a couple of questions for you to have a go at them. Pause the video, and then come back and check your solution against mine. Welcome back, here are my solutions. If you got the correct answers, move on to the next part of the lesson. Otherwise, I'll go through my solution now. In part A, we have 9 minus x squared. The 9 tells us that we're going to need 3 times 3. And then to get minus x squared, we require plus x and minus x. The 3 times 3 gives us the 9, the x times minus x gives us the minus x squared, and the other terms cancel, 3 times x and 3 times minus x. Part B, x squared minus 36. We'll need an x and an x to get us the x squared bit. And then to get minus 36, we want plus 6 and minus 6. X times x is x squared, 6 times minus 6 is minus 36, and then the other parts cancel, 6 times x and x times minus 6.